yesterday was 4-7 as well. Today's second day of 4-7. We're going to add some steps to it. So, same kind of learning goals as yesterday. I just want to add some more difficult problems. Okay? All right. So, here we go. Here's the first step. I want us to solve each and graph them on a number line. So let's start with those two. Okay? So, solving just like a normal equation. You can talk to your neighbor about what you're going to do first, but I'll be walking around helping. Why don't you compare your work right now with the neighbor and see if you guys have the same thing. Sure there.
Let's start number 2.
Then again, we weren't doing too hot. We still won. That's what a good team can do, though. We're not playing up to the best level.
What are you talking about?
We're not playing up to the best level.
What is that?
We still beat them.
No.
Yeah, it's obviously correct.
I wasn't going to say that.
I told you it was -1.
I wasn't going to say that. Thank you, Annalise. All right.
4 was never there. You imagined it.
Hey, can someone tell me what Annalise did first? What's that called? Yeah. Good, distributed property. So when she multiplied the 3 by the f and 3 by the -4 to get 3f minus 12, that's distributed property. Now the common mistake is forgetting to distribute that 3 back to that 4. So if you put 3f minus 4 versus 3f minus 12, you just forgot to distribute the 3 back to here as well. So you got to multiply it by both. Well done. And then we add 12, we get -3 and divide by 3. Sign doesn't flip because we're not dividing by a negative. Yet f is less than -1. It's open circle and shaded to the left. Well done. All right. Number 13. Let's check it out. First step. Anyone? Yes, Trinity? Distribute, okay. So we get 20 plus 8k greater than 44. Second step. Caden?
Subtract 20 from both sides.
Good, subtract 20. All right, so we get 8k is greater than 24. Last step. Brennan?
Divide 8 to both sides.
Divide 8 to both sides, okay. So 1k is greater than 3. All right, so that gives us our number line, 0, 3, open circle, and shading to the right. All right. Okay, tell your neighbor, is k or if k was 7, would that be a solution to this inequality? Yes or no? Yes or no, and why? Okay, volunteer. Who says yes? Who says no? Okay, everyone has to vote. Who says yes? Okay, who says no? Okay, so 7 is right here on our number line. 7's in the shaded area, therefore it's a solution. If I put 7 in for k, is 7 greater than 3? Yep, it's a solution. All right. Good. Any questions there? All right, want everyone try number 14. Okay, so check your work here. Compare it, make sure you match, or if you don't, let's try to figure out why. Why did he flip the sign right there? Good. Divided by a negative. So when you divide by that negative, remember to flip the sign. Good. Yeah, we'll graph it. So graphing, open or close? Open. Shading which way, left or right? Left. Is 0 a solution? Yeah, 0 is a solution, right? Because 0 is in the shaded region. Remember, we flipped the sign because we divided by that negative there. So the sign flips over. Jay, you got a question on it?
I'm confused. Why would you shade to the left then? The sign, the sign.
From here to here?
Yeah.
He just moved it so that the variable came first. And so notice your arrow, the point of it's closest to the B. So when you move the B over to this side, the arrow still has to be the point of it still has to be closest to that B.
You always have to do that, like switch it.
You don't have to switch it, but then the arrow won't, if the number comes first, the arrow won't point in the direction you shade then. So did you shade correctly?
No, I did it the other way.
Okay, so the only way the arrow points in the direction we shade is if the letter comes first. So if you want to do that, then you have to put the letter first, which means you turn that sign over. Good, other questions? All right, there's not a lot more to it. I do want you to try that problem there. Bit different. That's why I put try this. Otherwise, you might not know to try it. Okay, so we'll go distribute in first. 18x plus 42 minus 24. And we got our 18 over here still. Combine our like terms. All right, so we get 18x and plus 24. Or no, plus 18. Thank you. Yeah. Plus 18. And get 18. Subtract 18, we get 18x. We subtract it on both sides. 18x is equal to, or not equal to, but 0 is less than 18x. Is that okay? Yeah, 0 is a number. Okay, so now we divide by 18. And I divide 18. If I have nothing and I give it to 18 of my friends, how much do each of them get? Nothing. Yeah, it's like me saying, hey, look, all this stuff in my hands, you guys can have it. I'll share it with you. You get nothing. I don't have anything. So nothing. I wouldn't do that to you. So if I switch it around, x would be greater than 0. It's okay to have a 0. We just put 0, open circle, and shade everything greater than it. So it's okay to have 0. Sometimes students get to the 0 and they're like, oh, it's a no solution because it's 0. And that's not true. Okay? All right. Any questions there? What's it called when 0's on the bottom? So if I have 0 over 18, we just said that that answer is 0. Yeah.
Wait, if the 0 was below the 18,
Yeah, so like if I had 18 over 0.
that'd be a no solution, wouldn't it?
That's actually called undefined. We get to that a little later, but one way to remember it, if the 0 is over the fraction bar, the answer is 0. If the 0 is under the fraction bar, it's undefined. Pretty cool, huh? Oh, yeah. All right. You guys don't look as impressed. Wake up. All right. Give that a shot. Actually, cop it down first. Give you a quick reminder here on how to solve those decimal ones. Go ahead and tell your neighbor how you're going to get rid of the decimals completely to begin with. As your first step, how do you get rid of all decimals and make them all whole numbers? Tell these guys. Toki wants to know. You know Toki?
Do you know Toki?
No? Brendan knows. Brendan, what do you do?
Well, because they're all decimals, can't you just get rid of the decimals?
You could. Yeah, in fact, they're all one number behind the decimal, right? Each one has only one digit behind the decimal. That means if I multiply by a specific number, it's going to wipe them all out. What number do I need to multiply by? if I want to move my decimal 1 over, yeah,
10.
by 10. Yeah, how many were going to say 10? Yeah, it's 10, right? It's a base 10. That's the cool thing about the metric system is that it's base 10. You just move decimals. When I multiply by 10, if I multiply this whole thing by 10, it just changes this to 15 plus 21y is less than 11y plus 45. They're equivalent. You don't have to do anything to offset that later since you multiplied everything by 10. That's okay. All right? It's like if you had this statement, just to show that we're talking truth here. If I had 5 is greater than 3, that's true, right? Everyone agree? Okay, if I multiply it by 10, I now have 50 is greater than 30. Is that true? It's still true statements. Kind of what we're doing here. Okay? All right. So now you collect your y's on the same side. Move our y's. So I move these over. Okay. Those are gone. I've now got 10 y's is less than 45. And I have my 15 over here still. It's a positive 10y. Now I can move my 15. And some of you like to move the 15 first, and that's okay. So we get 10y less than 30. So 1y is less than 3. And we get our 0, our 3, our open, and our shade. All right, so applying a lot of what we've done this year. Okay. Any questions?